here we are with Brendan Farmer, Polygon co-founder and one of the brains behind Polygon zkEVM. Brendan, thanks so much for joining me and welcome to the Defiant podcast.
Thanks for having me. I'm really excited for it.
Yeah, so super excited for this conversation. Of course, Polygon is and has been at the forefront of scaling Ethereum, and you've been behind a lot of the intense technology and development that's required to make this happen. So yeah, I can't wait to get into the latest. But before we do that, I'd love to just get everyone on the same page on just the very basics. And if you could go over what Polygon is and also just clarify what the difference is between all the different pieces of Polygon, which there are a few, like there's the Polygon Proof of Stake chain, Polygon zkEVM, Polygon Zero, Miden. I don't know any other chains I might have missed. So yeah, if you can just get us all on the same page on that.
Yeah, sure. So Polygon is a project that's focused on scaling Ethereum. And that project began with the Polygon PoS chain, which is a side chain that's secured by validators and has, increased the capacity available to the Ethereum ecosystem. The sort of latest chain that Polygon has released is Polygon zkEVM, which is a full zkL2 that we released last year. But I think the best way to look at Polygon is as two things. So it's CDK and then the AggLayer, the aggregation layer. And so CDK is Polygon's chain development kit, and it's a technology stack that allows anyone to spin up a zkL2 on top of Ethereum. So in the future, Polygon PoS, Polygon zkEVM, they'll all use the CDK tech stack, as will a bunch of other chains that are entering the ecosystem. So OKX, A-Star, Manta, Doge chain, I believe, is coming on. And so CDK basically powers this ecosystem of individual zkL2s that exist on top of Ethereum. And then AggLayer is what connects all of those zkL2s and unifies liquidity and state and users across all those chains.
Got it. Okay. And then where does Polygon Zero and Polygon Miden fit in?
Yeah, so Polygon Zero is my team. We were acquired by Polygon in 2021. So it's a team that I co-lead with Daniel Lubarov, and we were focused on sort of cutting edge ZK R&D. So taking the underlying ZK technology and making it really, really fast. Polygon Miden is focused on building a new execution environment that's sort of ZK friendly and does really cool things like privacy and client-side proving. I think the right way to look at those two teams is as contributing technology that goes into CDK. So using CDK, you can choose whether you want to use a zkEVM, or in the future, whether you want to use Miden or other execution environments eventually too. And so I think I would look at them less as like individual products and more as teams that are working to contribute to this unified ecosystem.
Okay, super interesting. So if the main pieces of Polygon, as you described, is this developer toolkit to spin up different Ethereum layer 2s, and then the AggLayer is a way to unify all those layer 2s, then Polygon zkEVM and Polygon Proof of Stake would be, two chains that are kind of examples of what others can do with the Polygon development kit. I guess those would be the first two chains developed by Polygon's development kit. But the idea is that there will be a bigger ecosystem of many layer 2s that people can spin up with Polygon technology. Is that right?
I think that's exactly right. The Polygon PoS chain might take a little while longer to migrate to the ZK ecosystem, just because there's a lot of activity and there's a separate bridge, and it's complex to make sure that we can do that without putting any funds at risk. But certainly zkEVM is like the prototype CDK chain. And there are going to be a lot of CDK chains launching throughout this year.
Okay, got it. And then Polygon Proof of Stake, is that actually an Ethereum layer 2, or should it be seen as its own separate chain? I've seen kind of this debate.
Yeah, so this was an infamous debate, and I remember when we were thinking about joining Polygon, this was like
it's kind of an old debate, but I never kind of figured out which side.
Yeah, but it was like setting Twitter on fire, and I can say definitively, Polygon PoS is not an L2; it's a sidechain because it doesn't inherit Ethereum security, so it doesn't have like a mechanism like fraud proofs or zk proofs that basically guarantee that the operators of that chain can't steal funds from users. In the future, it will have that mechanism. So it will have a zk upgrade. And so there will be this guarantee that's provided by zero-knowledge proofs that everything that occurs on the chain is a valid transaction. So the operators of the chain can't steal funds from users.
Is there like an estimate on when proof of stake Polygon will be upgraded? Or I don't know if upgrade is a word, but
yeah. So we're aiming for this year. It's a good timing for this question because we just released a really big upgrade for the zkEVM that enables a type 1 prover. So when I talk about type 1 or type 2, that I'm referring to Vitalik's framework for classifying zkEVMs in terms of compatibility or equivalence with Ethereum. And so the really cool thing about a type 1 prover is we can take any EVM chain, whether it's an optimistic rollup, a sidechain, an Alt-L1, even Ethereum itself, and we can just start generating zero-knowledge proofs, proving the validity of every transaction. So we don't need to like change the client or do a migration or anything. We can just immediately start generating zero-knowledge proofs and upgrade these chains to a ZK-powered chain. And so for us, like that's really important when we think about the POS chain and upgrading it so it can join the AggLayer and this unified ecosystem that we're trying to build.
Super interesting. Okay, and before we go any further, I think we need to take a step back and just describe zero knowledge proofs. Like we've mentioned that it's this technology backing a lot of the development on Polygon. So what's so cool about it? Like why are so many layer 2s using it?
Yeah, so it's really cool technology. It allows you to prove that some computation occurred or that some output is the valid result of some computation with a really, really small proof. And so this computation can be really big. Like you can imagine it as being like executing 1 billion transactions on Ethereum. And I can prove to you that the result of that execution, the resulting state of that ledger is valid without having you execute all of the transactions that occurred in that billion transaction segment. And so this is really cool because from Ethereum's perspective, Ethereum doesn't need to know what's going on all these L2 chains. It can just accept a proof that everything that occurred on those chains is valid. And it can, like in doing so, like basically bind the operators of those chains to only execute valid transactions. They can't steal users' funds. They can't, create invalid transactions. They're basically like cryptographically bound to only behave honestly. And so it's this really, really cool technology for scaling Ethereum. I think it's just to like take a step back. It's a technology that's progressing and evolving really, really quickly. So Daniel Lubarov and I started this project called Mir back in 2019. And we were just trying to build a ZK-powered L1. So a chain that used zero-knowledge proofs to provide privacy and scalability. And back then, it was actually a really, really scary thing because we had raised money and we had no idea if this technology was even going to be performant enough to enable like simple transfers. So the idea that like the technology has progressed and we've been able to contribute a lot to its progression, but it's progressed so far that you can now generate proofs for the Ethereum mainnet. It's like a crazy thing that I think would have been like really mind blowing at the time. But yeah, it's been like an interesting ride.
Very cool. Okay, so as you mentioned, you before Polygon, you were co-founder of Mir, and so that was acquired by Polygon in 2021, and so this team became Polygon Zero, and you've been developing or you've had a large impact on Polygon's zero knowledge technology, like the development behind that, and so I guess like zero knowledge and optimism are the two main technologies behind layer twos. Just to wrap up the technical side of why this technology, how does it compare to optimism? Like, what are the different trade-offs between the two models?
So I think this is I'm going to try really hard not to offend anyone working on an optimistic rollup. I may fail, but I think that the really interesting thing about this technology and sort of the core difference is that when you're building on a technology that uses fraud proofs, you have this challenge period where it usually lasts 7 days, and it's basically this window of time where anyone can submit proof that the operator of the chain has behaved maliciously. So they can say, look, the operator of the chain included this invalid transaction, and they gave themselves 1 billion ETH, and we need to reject that transaction and ensure that it doesn't finalize on Ethereum. And so when you look at optimistic rollups and zk rollups, and when you look at a single chain, like you're comparing a zk rollup against an optimistic rollup, they look fairly similar. Like the transaction costs are pretty similar, if not identical. You can, with zk rollups, you can optimize on call data because you don't have to include signatures. And so there are these like small optimizations that you can make. But the transaction fees that users are paying are roughly the same. But the problem is that no user wants to lock up their funds, lock up their like highly volatile crypto assets for 7 days in order to withdraw them from the chain. And so they're forced to use third-party bridges in order to quickly exit from optimistic rollups. And so if you think about like the cost that imposes on users, like users are paying tens of millions of dollars in aggregate to exit optimistic rollups in like a time efficient way. And their counterparties are taking duration risk by locking funds for 7 days in these bridges. And so when you sort of like zoom out a little bit and you think about, okay, we don't just care about one chain. We care about like building a scalable ecosystem of chains that can accommodate the demand for block space across like, a bunch of different L2s and different chains. Then in that model, it actually like zk has a huge advantage over optimistic rollups because like we want to make this ecosystem of many chains feel like using a single chain. And we can't do that if the latency for trustless bridging between those chains is 7 days. Like we need a way to shrink it down so that it feels like instant, or it feels like something that's more user friendly than 7 days, or even like 30 minutes or an hour. And so I think this is like the core advantage for zk is like very, very fast, trustless bridging. And it's a really important component of the AggLayer and our vision for like taking this fragmented modular ecosystem and unifying it into an environment where liquidity and state is shared.
Okay, that's super helpful. And then that's a good segue to the next topic I wanted to discuss, which is the aggregation layer. And you recently published a post detailing this vision, and it's super interesting, the two claims that you make in the beginning, and there no single chain, whether L1 or L2, can support the throughput required to reach internet scale, which, super interesting claim, because that's what most L1s are trying to achieve. So you're saying that can't happen. And then scaling blockchains means scaling access to liquidity and shared state. Adding block space via multiple chains doesn't work if it fragments liquidity, which is basically what we've seen is happening with so many layer twos, springing up. So just, starting there, if you could, dive deeper into these claims, like why do you think, what do you mean when you make them?
Yeah, sure. So I think the first claim is targeting the monolithic view of scaling. And so the monolithic view says what we need is just a super, super high performance chain. And that's how we're going to satisfy demand for block space for the foreseeable future. And I think that if we are optimists and we believe that crypto is going to grow by orders of magnitude in the future, then those two worldviews are not consistent, because I don't think that you can run the internet on a single computer or a single data center. And likewise, you can't, there will always be bottlenecks and sort of contention for shared resources like bandwidth or compute or storage that make running a crypto ecosystem that's grown by 100 or 1,000x infeasible on a single chain. And so that's meant to be a challenge to the monolithic view of the world and the monolithic view of scaling. The second claim is basically saying that when we talk about scalability, we really mean scaling access to liquidity and to shared state. We can create, like you said, we can create a bunch of different chains and we can create all the block space that we want. But if liquidity is fragmented across those chains, if we can't easily move users and state between those chains, we haven't really achieved what we set out to do, which is to broaden access to liquidity and to shared state to many, many users. And so with those two claims, it's supposed to suggest that this disagreement between the modular and the monolithic view of the world, neither is really sufficient to get us to internet scale crypto. And we need sort of a third approach that we call the aggregated blockchain thesis, but is designed to basically take a modular ecosystem, one where you have many chains, and scale access to liquidity and shared state across those chains. And so you can have this the system that scales horizontally, where you can always add block space to meet demand, but you're not giving up the unified state and liquidity that we have on a single monolithic chain.
If you haven't already considered building your next smart contract in Rust, you gotta have a look at Soroban. You can migrate your existing Solidity smart contracts over to Soroban, and we'll show you how. You can also get funding for your projects. There's a $100 million adoption fund just to drive the adoption of Soroban, so you can help build the ecosystem and potentially qualify for grant awards up to $150,000. You can visit us now at soroban.stellar.org to learn more.
Technically, how does this work without, if you can avoid as much jargon as possible, explaining it very simply, how would this aggregation layer work?
Yeah, so stop me if I get too jargony. But the basic way that I look at it is you need two ingredients for unified liquidity, right? You need fungibility of tokens. So you need to be able to move assets across chains and not have this phenomenon that we have now with third-party bridges where you move ETH from chain A to chain B. And on chain B, you get wormhole wrapped ETH or some wrapped synthetic version of that token. So we need fungibility of assets across our ecosystem of chains. The second thing that we need is super, super low latency cross-chain composability, whether asynchronous or synchronous. And so the AggLayer is really targeted at providing these two things. So it uses a unified bridge to provide fungibility, and it ensures that that unified bridge is safe. You can't have a misbehaving chain drain the entire bridge. We know that we have this cryptographic guarantee that we can have fungibility across chains, and the like sort of overall collateralization of the system is guaranteed and safe. The second thing that the AggLayer provides is it provides this foundation of safety for cross-chain, like low latency communication. So right now, if I want to go from like one rollup, like one zk rollup on Ethereum to another, and I want to do it trustlessly, I need to go through Ethereum. So I need to like submit my transaction on chain A. I wait, maybe 5 minutes for a proof to be generated. I withdraw to Ethereum. So I wait another 12 minutes for that block on Ethereum to be finalized, and then I can deposit. And so the core of the AggLayer is providing safety for lower latency interaction on the order of a few seconds between chains. And so it basically says, okay, we are going to ensure that it's impossible. It's like cryptographically impossible for a chain to rely on the state of another chain that's invalid or equivocated or not consistent. And so like chain B can't accept a message or a transfer from chain A that's based on an invalid state of chain A. And so there are basically like two levels or two components to the AggLayer. The first is this like zk guarantee of safety. And the second is sort of these like emergent coordination mechanisms that exist on top of the AggLayer that actually facilitate interoperability between chains. So these could be like shared sequencers or relays or builders that allow chains to navigate trade-offs between liveness and low latency. But fundamentally, all chains enjoy this guarantee of safety that's provided by the zk component of the AggLayer.
Okay. So, I mean, does it work like a bridge? Like, do you send, say you want to transfer ETH from rollup A to rollup B, you would instead send that ETH via the AggLayer? And how would that work?
Yeah, so we have a bridge that's unified across chains that we call the LXLY bridge. And so
LXOI?
Yeah, LXLY. So instead of L2,
Okay.
L1, it could be L2, L2.
Oh, okay.
L1, L2. So it's just LXLY. So the nice thing is like if you have ETH on like let's say you have ETH on chain A and you want to swap it to USDC on chain B and send it back to chain A, you can initiate that transaction on chain A. And even before chain A and chain B generate proofs, they can rely on a shared sequencer or relay that's crypto economically secured. And that relay can pass a message from chain A to chain B. And so it can say, okay, Cami took 10 ETH, she's sending it to chain B, she wants to swap it and then send it back to chain A. And so chain B can say, okay, I know that there's a possibility that chain A won't generate a proof or they've generated an invalid block. But I have this relay that's running a full node for chain A and is saying, okay, I'm crypto economically secured with hundreds of millions of dollars staked. And I'm telling you that this transaction happened. And so as chain B, if I choose to trust that, I can immediately start generating a block even before a proof is generated for chain A. And I know that I have this guarantee that I'm committing to the claimed state of chain A so that when I submit a proof and when chain A submits a proof to the AggLayer does what's called proof aggregation. So it takes all of these proofs for all these different blocks that are occurring on the Polygon ecosystem, and it aggregates them into a single proof. And that proof is checking that, okay, chain B claims that the state of chain A is this. If the actual state that chain A submitted is different, then I'm going to prevent chain B from finalizing, and it's going to have to like revise its block. And so this is obviously not a great thing if there's like a 30-second or 15-second reorg. But the shared sequencer or the relay that chain B relied on would be slashed. There's a small amount of liveness fault that chain B needs to deal with. But fundamentally, it's impossible for chain B to rely on an invalid state of chain A and be finalized to Ethereum. And so chains get to like navigate these trade-offs between being able to offer really, really low latency to their users and like navigating the risk of liveness issues.
So it's like the transaction, you can kind of bypass Ethereum via this bridge, and you get to kind of initiate the transaction without waiting for Ethereum. But then you still have to, even if you start the transaction, you still have to wait for Chain A and for Ethereum to confirm that everything is okay before Chain B can actually receive the funds.
So sort of. It depends on your trust assumption. So Chain B can immediately start building blocks if it believes that the relay is unlikely to be acting maliciously. It can immediately start building blocks that depend on the message that it received from Chain A. Mm-hmm. But I think it depends on the user, like what level of confirmation you're relying on. So you know that like if you're going to buy a Lamborghini or a house or something, then you should wait the like 2 minutes for all of the proofs, for the proof from Chain A and the proof from Chain B to be aggregated and then posted to Ethereum. Because you know that in that case, it's impossible. Even if the AggLayer misbehaves, even if like every relay misbehaves, if Chain A and Chain B misbehave, it's impossible for that transaction to be rolled back. And so I think it depends, like many things in Ethereum and in like optimistic rollups and zk rollups, like what level of certainty and what level of guarantee you want to rely on. Like a lot of users now, when they're using optimistic or zk rollups, they rely on just the pre-confirmation from the sequencer. So before even the transaction is posted to Ethereum, or before the fraud proof period has elapsed, or before there's a zk proof that's posted to Ethereum. And so this is like a similar situation where like users and chains can pick the level of certainty and the guarantee that makes sense for them in their use cases.
Got it. Okay. And so this AggLayer would be useful for connecting all of the different Ethereum layer 2 rollups, or is it something, that's broader that can connect even non-Ethereum EVM chains?
So it's actually something that's a little bit narrower because you have to like opt into the AggLayer. But the nice thing is that with the type 1 prover, even if you're currently an optimistic rollup, or if you're an Alt-L1 or some other EVM chain, you can immediately join the AggLayer and start participating in the LXOY bridge.
Okay.
And so this is like a really cool thing because like we have all of this state and liquidity that's fragmented across a bunch of optimistic rollups and Alt-L1s and sidechains. And so the nice thing is that with the type 1, they can seamlessly upgrade to become zk rollups.
So you have to opt in, but any Ethereum rollup and any EVM chain can opt in.
Yeah, exactly. And there are no restrictions. Like in other L2 ecosystems, there's like revenue sharing, or there are restrictions on the clients that you can use, or you sort of have to respect governance. And for Polygon, like there are no restrictions. You can use whatever client you want. You can use whatever sequencer or sequencing mechanism you want, whatever token for staking or governance or gas. It's just like if you're like our thesis is, if you're bringing economic value to the ecosystem, that's a win-win because the Polygon ecosystem gets to take advantage of whatever NFT mint you're running on your chain, or whatever game or DeFi primitive, and vice versa. You get to take advantage as a chain of the existing liquidity and users and activity that's already happening in the Polygon ecosystem.
How is this maintained? Like, is it, I don't know, like similar to a proof of stake where you have like a bunch of validators securing this, or like who's behind it?
Yeah, good question. So the first version will just be running on a single server, and then we'll decentralize so that it like the proof aggregation and accepting transaction or accepting blocks and proofs will be run by Polygon stakers. And so I think that the important thing to emphasize here is that like you don't, as a user or as a chain or as a developer, you don't need to trust this service. It just exists to like perform this function for the ecosystem, which is proof aggregation and posting those proofs to Ethereum. But it can't misbehave and sort of steal funds or like equivocate to chains or do anything except, yeah. There's no like attack vector that this exposes.
So you're not sending funds to AggLayer. Like it's not handling any user funds. It's performing the service of like validating proofs.
Yeah, but validating, but also aggregating. So when we talk about aggregating, it's like you're creating a new proof that verifies two other proofs. So you take two proofs and you basically like compress them into a single proof. And so we can do this recursively to take like a bunch of different proofs into and compress it into a single proof that we post to Ethereum.
Okay, but again, it's not handling any funds.
Yeah, it's completely non-custodial. It can't misbehave. It can't steal funds from chains.
Okay. At what stage of development is it? Like, when can we expect to see it live?
Yeah, sure. So the first like baby step or milestone is launching the LXOY bridge. So the unified bridge that connects CDK chains. Mm-hmm. And this will be really cool because it will give the fungibility property that we care about. So if you have ETH on Polygon zkEVM and you want to move it to the OKX chain, you'll be able to get ETH immediately on the OKX chain. You won't get like zkEVM wrapped ETH. The downside is that all of the interactions will still rely on Ethereum, so it will be slow. Like there will be a lot of latency and cross-chain interaction. So over the coming months, we're going to be building out the proof aggregation and the sort of that underlying mechanism for safety so that chains can actually start to rely on shared sequencers and relays and builders. And so like for us, we view our role as providing that like ZK foundation for safety. And then we're relying on a lot of other amazing projects throughout the ecosystem to actually build the shared sequencers and the relays and sort of all this like coordination infrastructure that will allow chains to interoperate at really low latency.
How does this look like once it's working, all the pieces are in place? How does it look like for the end user?
Yeah, so I think that a really important component of this is like building UI and wallet infrastructure that kind of abstracts away the individual chains. So the goal is like you could have your funds on some like super low fee Validium chain, and like you don't even know where in the like aggregated block space of the Polygon ecosystem you are, but you know that like if you want to swap on Uniswap or you want to like claim a mint or play a game, you can access that with your funds seamlessly. Like you don't need to worry about like, okay, I need to like go to Wormhole or go to Stargate and then bridge to this chain, and then I need to be able to get ETH that's native to that chain. Like all of that will just be like, first of all, you don't need to use third-party bridges within the Polygon ecosystem. Tokens are fungible, but actually like getting your funds between chains would be like completely transparent to the user.
So I'm trying to think like, I don't know, like a specific dApp that uses, Polygon. In general, yeah, like there's this friction, right? When using Polygon based or any layer 2 based application where, maybe, you have a little bit of money in that chain in your wallet, and then you're performing some sort of action that requires you to have maybe another token, or maybe you need to buy, you need more money to do something, and that whole, going maybe back to your Ethereum wallet to transfer that those tokens back, it's a huge pain. So the idea would be to make that more seamless? Like you'd be able to simply, make that transfer without going through any bridges, or maybe even just like seemingly just like grab the tokens from a wallet that includes all of your tokens, no matter what chain they're on. I mean, that would be ideal for me.
Yeah, for me too. Yeah, so I think that's the end goal. I think that there are basically like 3 steps. So first is like building the foundation of safety that we call the AggLayer. The second is like building the coordination infrastructure and mechanisms that allow chains to like do super fast, low latency composability. And third, I think, which is equally as important, is actually implementing this in wallets so that we can like change how users think about their interactions with chains. And the problem obviously today is like you can't do that because like you need to expose to the users the security trade-offs that they're making. Like the fact that they're holding like some wrapped ETH that's like tied to this bridge that could be compromised. Like we can't get around that right now. But with the AggLayer, with the unified bridge, I think it really opens up the design space so that we can do something close to what you're describing, where you don't have to think about or reason about like where in block space your funds are.
Yeah, I think, hopefully we can get to that place where you just have one crypto wallet and all your tokens are there, and you have one ETH, not like 10 different types of ETH. And if you're in a game and you need to swap ETH for whatever in-game token, you can just do that in seconds without having to go through any sort of bridge. Or, if you want to sell USDC and maybe buy Bitcoin or like some other chain token, you can. That I mean, when will that happen?
I hope soon. Like we're definitely really hard at work on making it happen as soon as possible. But I think that like at least within Polygon, we at least feel like we can like sort of glimpse how to get there. I think in a way that is sort of sane and makes sense. And so I think that we're really optimistic that it will be. It's not going to be in the next few months, but it will be sooner than people think of.
Make your trades go further with Matcha, the DEX aggregator from 0x. Get the best prices on swaps with smart order routing and over 5 million tokens at your fingertips. Tap into more than 120 DEXs at once for the best value in DeFi and trade cross-chain for free across 7 networks. And with Matcha Auto, MEV protection will save you money as your trades settle quicker through private market makers. Trade on Matcha today. So this is just for EVM chains that opt in, which would include, huge ecosystems like, I mentioned Bitcoin, Solana, other, non-EVM chains. What do you think the pathway looks like for those chains and for the entire blockchain ecosystem? I mean, how do you think it can evolve? Like if this infrastructure or this architecture really does take off and it's all the EVM chains opting in and there's a lot of liquidity and interoperability, does that mean that non-EVM chains that don't, work with this system, do you think that they just, become less relevant, or do you see a way of just like connecting all of these different EVM and non-EVM chains?
Yeah, I think that's a good question. I think my personal view is that EVM is where we start, but it's not where we finish. And someone the other day said this thing that I really like, that like zk allows us to take all of these different execution environments, all these like heterogeneous VMs, and project them down to Ethereum. So like with zk, we can imagine connecting like Solana or some different VM, or like building custom VMs that work really, really well for specific app chains like DEXs. And like from the perspective of Ethereum or the AggLayer, they don't need to know what's going on in those chains. They only need to know that there's a zk proof and that it's presumably ensuring that all transactions in those chains are valid. And so that advancement in zk tech would allow us to branch out beyond the EVM into like different execution environments while still maintaining compatibility and composability with the EVM.
Is that like some really far out dream, or do you think that's something that can more imminently happen?
Yeah, it's an interesting question. So one thing that my team is hyper focused on at Polygon Zero is trying to push the underlying state of the art in zk tech further. And so we have this library. We released this library called Plonky 2, which at the time was like this groundbreaking performance improvement. And we are really hard at work on Plonky 3. And the cool thing about working in an open source ecosystem is that other people use your work and build on it. And so this team, this really talented zk team called Succinct, released what's called SP1, which is a zkEVM that runs it uses Plonky 3 as the underlying proving system, but it allows you to take Rust code and to compile it to run in zk. And so this is like a really cool step for imagining like how we would take these different execution environments like Solana or like Move or building custom execution environments for app chains, and how we would add zk tech to allow us to generate proofs for them. So I think like we still have a ways to go in terms of efficiency, but I definitely think that we can like have a fairly high degree of certainty that this will happen in the future and it will be pretty performant.
Very cool. So like as you're explaining all of these things, it feels like there's just a lot of complexity, just like many layers and upon layers of tech that needs to be built, of chains that users need to go through. And in that sense, the argument for a monolithic chain is kind of attractive. It's this idea that, we're building a single chain that's super fast, super performant, that can scale to support a billion transactions or whatever, that can be, the thing that supports the financial system and the internet. I mean, what do you say to that argument? I know you said that can't happen, but there's a lot of people who say that it can, and at the same time, I don't know, like this future where you're relying on so many different layers and technologies and things sounds a bit risky. So I don't know. Do you think it can? Do you think there's no way that a monolithic system can work, and how do you mitigate all those risks?
Yeah, so I think, and I'll try not to get like too spicy and offend anyone. But,
get spicy, it's fine.
So the way that I look at it is like there's an analogy which is it would be like if we tried to run the entire internet on a single computer. And so I think that there are two issues with that. So first, I do think that there are just inherent scalability limitations that we will run into on monolithic chains. There are just limits in like bandwidth and like the amount of memory that we have access to, and like the cost of replicating state across a bunch of different machines. But even if you deny that, I think that there's just this inherent problem with monolithic chains, which is that they host like there are a lot of applications in crypto that have very, very different requirements for functionality and for security and for decentralization. And with a monolithic chain, you're basically forcing all of those applications to contend for resources and for block space. And so you have the ability, you have composability across this chain, but like, does an AMM or a CLOB need to compose directly with a game that people are playing? Like, probably not. There's probably some degree of like asynchrony or latency that we can accept between like super high value DeFi applications and like games. And so I think like if we want to accept like heterogeneous requirements for applications, then like a modular ecosystem works. And like, obviously, I believe very strongly that we shouldn't be relying on a single chain. And like nothing that we've seen suggests that we can scale a single chain to, 3 or 4 orders of magnitude higher throughput. And so that's what I would say. I do think like, as we're describing this and as we're sort of like building out the conceptual framework to think about the AggLayer and like ZK powered ecosystems of blockchains, it sounds like there's a lot of complexity, but I think that there are ways that we can sort of mitigate that complexity, that we can make it opaque to users, that we can sort of create a good user experience even as we navigate some of the technical challenges on the back end.
Yeah, I hope so. And beyond, making it, abstracting it from users, I assume even if you abstract it, there's still, the greater the number of systems that you're relying on, the greater the risk, right? Like if something fails down the line, you're now trusting that there's, that all of the chains that you're using to make one transaction behave. So I think that's kind of the thing that makes me a little bit, not worried, but I think that's kind of, maybe that would be a concern if I'm, for every transaction I make, having to rely on 3 different chains.
Yeah, I think that's fair, but I think conversely, is it better to rely on a single chain that might go down and take everything down? And so,
yeah, that's a good point.
I think that like there are definitely trade-offs, and I think that like as an ecosystem, we just need to figure out and solve these like core engineering problems around like how we guarantee reliability and uptime across many different chains. Like I do think that it's easier to think about maintaining and running chains that have like lower than 1 million TPS throughput. And so like I do think that there's some sense in which we're able to kind of break those big problems down into something that's more manageable in the modular approach.
Right. No, that makes a lot of sense. And now talking about use cases, you're at the forefront of scaling. What do you think will be the application that brings in the next wave of users? Yeah,
so I am maybe not the best person to ask about this because I feel like when you're building infra, it's really easy to take the position that if we build it, they will come, and that some brilliant developer somewhere is going to make this amazing application and will sort of like justify all this like hard work and effort that we're putting into scaling. I will say, like, just on a personal level, I think that there are 2 things that are pretty cool. I think that like seeing more of this interplay between Web3 and Web2. And so that's like there's this really cool project that's zkP2P that's doing, they're verifying zkEVM proofs. So you're able to like verify that something like basically a Venmo transaction occurred. So you can get around this on-ramping problem where right now you have to go through an exchange or something. I think that similarly, like Farcaster is a way that we can put like some state on chain, but we can replicate sort of a Web2 experience by having a lot of the state off chain. And so I think like seeing instances in which crypto is like either replacing or augmenting the existing web, I think is a really, really cool like set of use cases and category. I also think that like privacy preserving exchanges. So there's this project called Penumbra that's doing something that like actually is impossible in TradFi, which is like you can have privacy preserving trades that that even like the operator of the exchange can't see who's trading what or like how you're transacting. And so I think that that's something that's really cool because it's something that like fundamentally doesn't exist in TradFi.
So you think it'll be financial applications the thing that continues to bring in people to crypto?
I think so. I mean, I think like it's tough to get away from the fact that like the underlying utility is financial, and like the underlying innovation is basically permissionless financial transactions. And so,
Totally.
yeah, I mean, for me, that's like the big thing. But I do think that, you know, there are ways to like use crypto to get around rent-seeking monopolists in Web 2, and that's like a cool thing if it can work.
Nice. Okay, and then to wrap up, what are, you know, some of the major milestones that your team and Polygon more broadly are working towards? Like, what should we expect from Polygon in the coming months?
Yeah, so the initial V0.1 of the AggLayer, which was the unified bridge, that's coming later this month. And so that's really exciting. And then obviously we spoke a little bit about the type 1 prover, but seeing that power chains, and also taking sort of the innovation and breakthroughs that we made in developing the type 1 prover and applying them to existing, like the Polygon zkEVM, and continuing to boost throughput and performance of CDK chains. I think it'd be really cool.
Awesome, Brendan. Thank you so much for taking the time. Super interesting and really, clarified the kind of bigger vision of Polygon really well. And yeah, this concept of the AggLayer as well. If it does lead to a more simpler user experience, I'm all for it. I hope it comes sooner rather than later, because right now it's a bit painful. But yeah, again, like, thanks for joining me. Amazing to talk with kind of the brains behind Polygon CK.
Yeah, thanks for having me, Cami. It was really fun.